everyone, welcome back to the channel. Today we're going to be talking about another statistical tool, which is hypothesis testing. Yeah, this is a simple topic, let's say, compared to the other topics in statistics, but it can be confusing to other people because it's so simple that you tend to want to skip the steps to the end, and then people usually get it wrong or get confused or think it's complicated because of that, because they end up getting the answer they get compared to the correct answer. They found that it's not right and they wonder, why is that? The main thing is because they didn't follow distinct steps while doing it, because they skipped them. They think they're too easy or it's not important, and then you end up interpreting it wrong. But it's a simple technique. So here's steps that I recommend people using in terms of when you're doing an hypothesis testing, right? So what is really hypothesis testing? It's a simple thing. You're just testing, does what you're thinking or hoping to find, is it true or not, right? So in hypothesis testing, we call that either you're accepting something or rejecting it. Rejecting a hypothesis. Hypothesis is just what you think, right? It's either you're rejecting that or you're accepting that, right? So number one, write down the new hypothesis. So the new hypothesis is hypothesis that is saying, the thing you're trying to test. Let's say you have a drug you're trying to test. Does it have an effect on this disease or not? Your new hypothesis will be this drug doesn't have an effect, right? Just simple as that. The thing is, most people don't write that down. They think it's obvious. I'm not going to write that down, right? And then at the end they start to think, okay, so what do I do? Which one is the new hypothesis? And then you interpret it wrong, right? Because at the end it's a flip of a coin, right? But then if you do it right, like follow the simple steps. Number one, write down the new hypothesis. It's quite simple usually. It just means there's no significance, or this thing has no effect, or whatever it is, right? Write it down. So actually physically write it down. And number two, write down the alternative hypothesis. So the other one is just the opposite of the new hypothesis. Again, write it down so that it's clear in your head. You don't get confused as you go along. If you just put these in stone, set the two alternative and new hypothesis in stone, set them in stone, and then whatever you decide after that, you're just either picking one or two as you answer, right? So write it down. Again, people don't write it down, which is one of the reasons why you get it wrong at the end. Okay, so if you write those down, that's number two. Step number three, find the criteria range for accepting either one of those, right? So you usually look into the perspective of one of them, right? Usually the new hypothesis, because they're opposites. So if I reject number one, it means I'm accepting number two. So I don't need to think about that, right? So usually people use the new hypothesis. It's that you're rejecting it or you're accepting it. So if I reject the new hypothesis, it means I am accepting the alternative one, right? If I'm accepting it, it means I'm rejecting the alternative one. It's that simple, right? So yeah, just use the new hypothesis, and then the criteria, set the criteria of accepting or rejecting that, right? So find it. So if it's a Z hypothesis testing, find the Z range that you're going to use to either accept or reject. We're going to talk about that. Or if it's a T test or T hypothesis testing, then you're using the T tables, right? So you find that range, right? Before you move on, find the range of accepting or rejecting H0 or H0 or new hypothesis, right? The third thing you do, I know that it seems like a complicated whatever, but these are actually simple steps. But just follow them anyway. They come naturally. You don't have to memorize them. But just follow them so that you don't then end up in trouble at the end when you're interpreting this, right? So calculate the Z or the T value for the question. So that's the range that you'll be comparing the T or Z value that you get from your question, right? So we'll actually use a question if this is not really making too much sense. We'll use an example, right, where we are following the steps, right, in the example. And then number 5, compare that value that you calculated with the one in the tables, right? So either the Z or the T tables, right? So the hypothesis testing is either you're doing a Z test or a T test. There's also F test, which is the ANOVA and stuff, but that's not usually asked in a written exam kind of thing. So usually it's the Z test that is asked in a written exam kind of thing, right? So that's what we use in this lecture. So yeah, so find that, compare it with the one in the tables. That's number 5. Number 6, if the calculated value is within the criteria range. So you compare number 4 and 5 values pretty much, right? You either accept or reject the null hypothesis, right? If you compare the value you get in number 4 and the value you get in number 5, you either accept or reject the null hypothesis, right? And then number 7, I put it in red because this is where the problems comes. If you don't follow the steps, number 7, you might get it wrong even if you did everything right, because all the other steps, trust me, you see when we do the question, they're actually easy steps, right? They're not complicated. But then number 7, you might be scratching your head there in terms of so what do I interpret the results? What does it mean in English? Right? A lot of people struggle there mainly because they didn't do step 1 and 2. They didn't write down what they are accepting or rejecting, right? So when you write that, just interpret the results using normal words, i.e. without using I reject or I accept the null hypothesis, right? We're just using the word, like for example, the drug works, or the drug doesn't work, or the drug is a significant effect, or the drug doesn't have a significant effect. So that's pretty much a line. It's a simple line in question 7. A lot of people struggle to find that line to say it because of, they didn't write down what they're accepting or rejecting. Anyway, let's use an example then to just kind of clarify things. So this is an example of hypothesis testing. You have, in a river monitoring study, 15 water samples were taken at a particular location, and the chloride content of the samples were measured, giving a mean of 548.1 milligrams per liter and a standard deviation of 22.5 milligrams per liter. Right. So in the steps, remember I was saying it's either Z or T value and whatever. How do you know which one? So whenever you are given the standard deviation, you're going to be using the Z tables. So when they give you the standard deviation, the population standard deviation, you're going to be using the Z table. So that's a giveaway, okay? And then, when you're given like something like degrees of freedom and stuff like that, then you're using the T tables. So these are kind of like clues which one you're going to be using. So in this case, which is usually the case in written exams, they usually ask for the Z values or Z tables stuff. So, we're going to use the Z tables. They give us the standard deviation, right? So part 1 is asking, test the hypothesis that the average concentration of chloride in this area of the river is 560. So they're telling us outright that the mean is 548, right? But they want you to test this hypothesis that, the mean could be 560, right? So it's either it is or it isn't, right? So they want you to test that, is it or is it not, right? So use a two-tailed test and 5% level significant. So 5% level significant is the same as 95% confidence, right? That's what you're going to use, and state clearly the alternative hypothesis. So here they're actually giving you marks for actually writing down the alternative hypothesis. A lot of people don't write it anyway when they're doing hypothesis testing. There are a lot of people who get it wrong, don't write that alternative hypothesis, right? So here they're actually giving you marks to write clearly what it is. Okay, so and then part 2, they just want you to construct a 95% confidence interval of that question. Again, there's another video on confidence interval, you can look into that. But we're going to do that here anyway as well, just to construct that, right? So this is the question, and we're doing hypothesis testing. I've just put the steps on the left, and then I'm going to be walking through those steps and just filling in the values. So first, write down the new hypothesis. It's clear, the mean is 548. So the new hypothesis is the status quo or the current state. So in this case, the current state is they told us the mean is 548. So that's our new hypothesis. And the thing that we want to test is the mean not that, right? In this case, 560. So we just do the opposite. So it's either the mean is 548 or it's something else, like 560. So the alternative hypothesis would be the mean is not 548. So these are usually the opposites of each other, right? So they're easy to write. So if you just find the new hypothesis, which is saying the mean is 548, the alternative then, you would say the mean is not 548.1, right? And that's it. So that's the steps that a lot of people miss, and they get the question wrong at the end in terms of interpreting it, but it's quite a simple step. And then number 3, find the range of accepting or rejecting that new hypothesis. The new hypothesis is saying the mean is 548. So how do we accept or reject that? Okay, how do we decide, is that true, is that not? So you look at the bell curve, so we're assuming this is normally distributed, right? So that we can use the Z tables. You look at it, they said 5% significance, so that means 95% confidence. So we put the 95% there in the bell. So in the middle, that's 95%. That tells you that on either side, there's the 2.5%. Or if you want a decimal, there's 0.95 in the middle, and then on either side of the tails, there's 0.025 and 0.025 to make the whole 100%, right? So you want to find the Z values that are within that are covering that range, that 95% in the middle, right? That's what it means, 95% confidence or 5% level of significance, right? So you have that 95 in the middle, so you want to find the Z values that correspond to that, right? So you notice that you have the 0.025 and then the 95 right in the middle. So the actual value that you'll be looking at in that range will be the 1.6, 1.96 and minus 1.96 in the Z tables, right? So there's another video that I can show you about the Z tables, which is a video about confidence intervals. So you can check that out if you're kind of confused where this is coming from, how to read this, how to find those Z values, the minus 1.96 and 1.96. So those are the Z values you get in the Z tables, right? Those two. So that's the criteria range for accepting or rejecting the null hypothesis, right? So yeah, we just write that out. So at that confidence level, the Z range is minus 1.96 and 1.96. So those are the two values. And then number 4, we actually have to calculate the Z value for our data, right? So our data, the Z score, this is a popular formula. It's Z score is equal to X minus mu, or the mean, over sigma, or the standard deviation. So X is the value you're testing. In this case, it's 560. So we're trying to test 560. Mu is the mean value. So the mean of this is 548.1. And sigma is the standard deviation. In this case, they told us is 22.5. So I just put that in the formula, and then I get the Z value for this. It's 0.53. And then, so now we did number 4 now. So we calculated the Z value for this question. Now number 5 in the steps, we compare that Z value we just calculated with the criteria range. So if our value is within that range, so if it is in the middle, somewhere in there, in the middle of that bell curve in here, if our value lies between these two values in here, we accept the null hypothesis, right? So if our value lies in here, we accept this idea that the mean is 548.1. That will be our answer, right? But if it is outside, the mean is not that, okay? So if our value, our Z value that we calculated was here, for example, it actually means the mean is lower than that. So something like, some other lower value like 400 or whatever. And then if it's on this side, it means it's higher than that, right? The mean is higher than that, like could be 560 or something, right? So in this case, then we go in and we compare. So we go to number 6. If the calculated value is within the criteria, so if the calculated value is within minus 1.96 and 1.96, we accept HO. So in this case, our value is actually within that range. So 0.58 is actually somewhere here, right? So this is 0, these are negative, and then this is 0, this is a positive values, right? So our 0.58 is somewhere maybe here, right? So that means it's within that range. So if it's within, we accept the null hypothesis. So our answer then, our value is within the range, hence we accept HO. And then the final step is the interpretation, right? So because we are accepting HO, we are saying the mean is 548, right? Which means that it's not 560. So the question was, is the mean 560? So our interpretation, now putting it in English, we say no, it's not, because we accepted the idea that the mean is 548, so it cannot be two things. So the mean is 560. So that's how you would do that. And yeah, just the question clearly says, state clearly the alternative hypothesis. We said it, so there it is. The mean is not 548.1. And then here you have another hypothesis testing example. So usually you might need to construct then a confidence interval after that. So that's part 2. Construct a 95% confidence interval for the mean concentration of chloride in the area, right? So again, 95% is one of the common confidence intervals. Again, you can watch the other video about confidence intervals that talks about this. But 95%, there's 3 formulas there: 68%, 95, and 99.7%. They are the common confidence intervals, and you can just remember how to do them. At 68%, it will be the mean plus or minus 1 standard deviation. That's how you create that interval. At 95, which is what we're looking for in this question, it's mean plus or minus 2 standard deviations. And then at 99.7, it will be mean plus or minus 3 in this case, standard deviations. Right, so we're going to just pick out the 95%. So we again, if you have a different value that is not one of those 3, you have to use the Z tables. Then there's another video that actually talks about 99% and other percentages, right? That you need to use the Z values to hunt down the number of standard deviations you have to find. So in this case, we're just using number 2. So the mean is 548.1 plus or minus 2 standard deviation. The standard deviation is 22.5. You just do the calculation. So the mean is in the middle there. If you do the minus, so 548.1 minus 2 standard deviations, it will be 503.1. You put the mean in the middle, and then the upper limit will be 548.1 plus 2 standard deviations, which will be 593.1. And then that's the confidence interval. So thank you for listening. See you in the next video.